Our next speaker is Captain Murray Stein, who's the director of the Seward Marine Center, School of Fisheries and Ocean Sciences, University of Alaska, Fairbanks. Murray Stein is Marine Operations Director at the Seward Marine Center, and he oversees the Sikuliaq, which is operated by the University of Alaska, Fairbanks.
See, we're on the right. We want to show the other one first. We want to show the other one first.
He's a growling, all away the bowling, the bowling, ho! All away the bowling, the foretop gun a bowling, all away the bowling, ho! All away the bowling, we'll either break or mender, all away the bowling, ho! All away the bowling, we'll haul away together, all away the bowling, ho! All away the bowling, we'll haul for better weather. All away the bowling, ho! Sally is the gal down in our alley. Way, hey, bully in the alley. Sally is the gal in Shinbone Alley. Bully down in Shinbone now. So help me, Bob, and bully in the alley. Way, hey, bully in the alley. Help me, Bob, and bully in the alley. Bully down in Shinbone now. Now Sally is a gal that I love dearly. Way, hey, bully in the alley. Sally is the gal that I spliced nearly. Bully down in Shinbone now. So help me, Bob, and bully in the alley. Way, hey, bully in the alley. Help me, Bob, and bully in the alley. Bully down. We'll
to the ship is not. So thank you for letting me take you to see it. Sikuliaq is NSF's newest and most capable research ship. And the things that we've been talking about the last day and a half, many of those things were brought to fruition aboard the Sikuliaq. So the ship's particulars, I came aboard in June. If you have any deeper questions, we have Rose and Bob Houtman who were here from the beginning of the project. The Sikuliaq is 261 feet long, the draft of 18.9 feet. The beam is 53 feet. Cruising speed is 10.5 knots. Her endurance is 45 days. Capable of breaking ice up to about a meter thick, 2.5 feet, at 2 knots. She berths 26 scientists, and that includes technicians and 20 crew members, 2,100 square feet of lab space. She can carry 4 20-foot containers on deck. Deck work area 4,360 square feet. Holds 13,000 gallons of fresh water, can make 6,000 gallons of fresh water per day, and holds 185,000 gallons of fuel. And the vessel is ADA compliant. So we heard a lot about bottom coatings. Sikuliaq has a very special bottom coating. It had to be hard enough to hold up in ice-breaking conditions. It's a very hard, non-ablative bottom coating. We hauled it out in February, and the coating is holding up very well. In warmer weather, we're finding that it gets a lot of growth on it. So we moved the vessel down to San Diego to get some work done on her and pick up a cruise, and probably before we start out on our next expedition, we'll have to have the bottom cleaned. The nice thing is that the growth comes off very easily. Again, I'm really surprised that it's held up so well. We have typical incinerator waste management capabilities. The incinerator will use either solid waste, or we can use our waste oil. It complies with both US and European standards. And since we are able to fuel the incinerator with waste oil, we don't need to burn diesel fuel. That saves us a few bucks on the fuel bill. And if you're aware, disposing of waste oil shoreside is very expensive, and the fewer petrochemicals we store aboard the vessel, the safer the vessel is. So we have the integrated power plant concept. And the Sikuliaq is the system combines both ship service electrical power and ship's propulsion into a common electrical plant. We heard a lot of discussion about this. We have 4 main engines on board, 2 16-cylinder and 2 12-cylinder MTUs, as necessary to support any combination of the hotel load, the science operations load, winches, cranes, and the propulsion load. By reducing our overcapacity conditions, in other words, we don't have to have more engines online than we need, we save fuel, reducing costs, and mitigating our environmental impact through reduction in our carbon footprint. We also have a waste heat recovery system. This is pretty cool. We already, when I worked for Scripps, we had a waste recovery system, and it was a hot tub out on the back deck that our clever engineers put together back there. We use a waste recovery system, and the way it works is the system recovers the waste heat from water jackets and from the exhaust systems for heating the interior of the ship and for heating potable water. This results in reduced energy consumption of and for heating the vessel by taking advantage of the waste that would normally be lost to the cooling and exhaust systems. We use biodegradable hydraulic oil and a few other biodegradable lubricants. I don't think we're using the biodegradable thruster oil yet. We're talking about going to that as soon as we can have the seals upgraded. And when I was sailing in other institutions and aboard this vessel, the most common leaks that we experience are oil into the water was a burst hydraulic hose. And unfortunately, we've had a couple of those incidents in the last year. Just a few drops in the water. We cleaned it up, called the Coast Guard, and when they heard it was this biodegradable hydraulic oil, they didn't even come down to the ship. They just said thank you and moved on. We also have a double bottom hull. Most ships are being built this way. So no fuel or storage tanks next to the shell of the vessel. And that, of course, reduces the potential for spill in the event there's an accidental grounding. We have the MTU 4000 series. They're Tier 2 emissions compliant, and it meets the MARPOL Annex 7 combustion exhaust limits. And we have the MSD, and this is probably one of our biggest management problems right now. We're having a hard time treating all of the gray water. It does a really good job on black water, and that's important because fecal matters. And this was the most advanced system available when Sikuliaq was being built, and we're working towards sort of figuring out a way to deal with the gray water. Ballast water treatment. We use the Guardian system, treats 100 cubic meters an hour, and it's relatively trouble-free and does not put any chemicals in the environment. Trash compactor, see these aboard most ships, and we can compact it and burn it or dispose of it ashore. Hull configuration and propulsion. This is important for us. Underwater radiated noise is a problem both for science, and we work in the Arctic region where there's a lot of marine mammals and a lot of subsistence hunting activities up there, and we want to make as little of an environmental impact as we can up there, and we don't want to interfere with the subsistence hunters. We also have major machinery mountings. Everything's soft mounted. You can actually move the big gen sets, and all of that was to reduce the noise transmitted through the hull. Propellers designed to minimize cavitation, and all throughout the vessel there's noise dampening treatments, extensive use, overheads, joiner bulkheads, structural bulkheads. A lot of time and money was spent to make this a very quiet vessel. We do the tests. We just got the final tests in, and we really look good compared to other vessels in the area. Anyway, what one would take from that, if they could understand it, is that the Sikuliaq is a very quiet vessel. That's it. Thank you.